Hey everybody, what's going on? It's Mr. Hino with Mr. Hino's Lego Robotics. Today I brought back the EasyBot. If you didn't see the original video that I did on the EasyBot, it's a super simple robot to make. I'll leave that video link at the end of this video, but I brought it back for three reasons. Number one, in the original video, I did not have a ball bearing in the back, and I showed you how to build this, and I was just not happy with the setup in the back that I had. It just didn't give this robot an accurate way of maneuvering around. So I'm gonna give you instructions today on how to put this ball bearing on. The second reason is I wanted to be able to show you how to attach any sensor onto this EasyBot. And somebody last time said, hey, that's a really cool robot, Mr. Hino, but you can't use it in First Lego League. And I want to show you today how to put a medium motor on to do some First Lego League missions. So if you want to see all three things, stay with me. And after watching this video, if you like what you see, go ahead and hit that subscribe button right there. Come on, I know you can do it. Okay, the first step is going to be how to make this. So what I'm going to do is go through the steps on how to make this EasyBot. I timed myself, and it took about 10 minutes. That's how fast this robot is to make. Obviously, if you have all the parts and pieces ready, it should be fast. If you have to search for it, it might be a little longer. But what I'm going to do is go ahead and let you just flip through the slides or pictures that I took of how to make this. And then I'm going to basically today show you how to put your sensors on, show you that this can be a super easy line following robot. And then what I want to do is put a medium motor on this guy to show you that, hey, you can do some First Lego League missions. So let's first go to the build. Okay, so now that we have this color sensor on, let me go ahead and show you real quick the two programs, a brick and a computer program, on how to turn this guy into a line following robot. Okay, let's go on the brick and make this real quick, fast and easy brick program on how to line follow. So what we're going to do is go to the third tab and we're going to go to your brick program right there. Okay, so we're going to go up and we're going to go ahead and do the move tank. And this doesn't actually really matter. You can make it a right turn or you can make it a left turn. It doesn't matter. So let's just keep it a left turn. So we want our robot to do a left turn. We're going to go to the right and we are going to go up and add the color sensor block here. And this is going to be for reflected light. So this is going to be, I'm going to start this robot on the black. Now black usually gives somewhere in the area, depends on how lighted your room is. It usually gives somewhere in the area of 8 to 9% reflected light. I don't want to necessarily get crazy and go all the way down to 10. 25 might actually be fine, but to be safe, I'm going to keep it at 35. And you can mess with this number, you know, as you need to, but so the robot's going to do a left turn if it sees under 35% reflected light, which is the black. Now let's go to the right. We're going to add another move tank block, but instead of it being left like that one, we are now going to make it go to the right. So basically, if it sees under 35% reflected light, it's going to go to the left. And then when it goes onto the white, we now want it to go to the right. So we're going to go to that same color sensor block for light intensity here, but we need to make sure we now go to where it says greater than or equal to. And I feel pretty comfortable with 50%. The white paper or the white track that I'm going to use, it's somewhere in the area of 70% for the white. So 50 is actually pretty good. And then the last thing to do is just go to this very end block and make it for infinity or just looped. So let's go ahead and take this to the track and watch this go. Okay, my robot is ready to go. There's just a few things I want to remind you if this thing does not work. Number one, always check to make sure your color sensor is plugged into the right port. My students sometimes forget that. The program defaults to port 3, so just make sure you move it if you have it in a different port. Also, you want to make sure your color sensor is not too high or too low. I get a chance to tell you Mr. Hino's saying, if you cannot see the glow, it's too low. So let me just kind of like tilt my head here. Notice we can see the glow. Sometimes my students, you can't see that red light. And basically what's happening is you're not allowing the light to go back up into the sensor if it's too far down. So that's one troubleshooting tip you might want to just keep in mind if things don't work. Sometimes the light just can't come back up here and the sensor can't read the program, thus just messes up your entire program. So without further ado, let's go ahead and check this out. It's going to have that windshield wiper effect because again, it's seeing black and going to, I think it's going to the right. It sees white, goes back to the left. So this program just has it going back and forth. Now you're probably saying, well, this thing is going pretty slow. And you're right. Keep in mind that the EV3 default motor speed for the brick program is only 70%. So obviously if you want it to go faster, we're going to need to go onto the computer and just bump up the motors. Also, what affects the speed is the number of, or the percent of reflected light intensity too. If you want to mess with those numbers, that can make the robot go faster or slower also. So remember, this EasyBot just a 10-minute build, and that color sensor was super easy to put on. And voila, we have an instant line following robot. So what's neat to tell students is, you know, they have robots in factories that follow the same kind of process here, where the robot takes things to various places in the factory, and it follows lines. They have robots. I'll leave a link in the description to line following robots in a restaurant that actually take food to people, and you'll notice in the video they follow the same line. Really cool when students see that. They're just like, no way. And they can instantly make the connection to, you know, a robot that can do this all by itself. So, you know, we can find a different job for these people that, you know, take food to people. Now they can be used somewhere else, or, you know, we can create more jobs for people that program robots. So, all right, now let's go ahead and hop on the computer to see if we can make this thing go faster. Before we actually go to my computer, I just want to be able to compare these times. So as soon as I press the button, check your time on your video, and I'm going to basically start it right here. If you can see this straight line that comes through the circle, and then I'm going to stop there, or look at the time when it comes back to see how long it took for this robot to go around this track one time. Are you ready? On your mark, get set, go. Okay, be ready, and stop. Okay, so go ahead and take a look at that time, and let's compare our times. Okay, everybody, let's compare times. I had 42 seconds. And if we can't agree, maybe we can just agree that it's in the area of 42 seconds. So what we're now going to do is we're going to go to my laptop. Let's go ahead and do a computer program and put it back on the track, and we'll compare that time to the 42 seconds. Let's go. Okay, everybody, I'm on my laptop here. Let's go ahead and program a line following program that will just get this guy to go around a lot faster. What we're going to do is we're going to first go to your flow control, and we are going to drag out a loop. And then we are going to put a switch inside of our loop. Ooh, let's get this thing to come down a little bit here. Okay, much better. Okay, now let's go ahead and come up here. This is going to be for our color sensor in port 3. And we're going to be comparing reflected light intensity. Okay, so this 4 here just means less than, so we'll leave it as less than. And this number here is referring to the black line. So that black line again is around 9%, 8%, and so 50 is just, it's a little too high for me. So we're going to keep this at, we're going to go put it to 25. So basically what we're going to do is we're going to make this program say if it's less than 25% reflected light. Now let's go to the green section here. We're going to bust out a move tank here. We're going to turn it on. We're going to put in another move tank and turn it on. Yep, my motors are plugged into BC. You can mess with your own numbers here. There is no perfect number. I usually will go -5.
let's go ahead and go all the way up to 100. And then here we're just going to flip the numbers, 100, -5. So basically we're going to have this motor speed going at as fast as it can, and we are hoping that it comes off the line a whole lot less than it did with the brick program. Obviously, like I said, the motor speed right now is at 100. On the brick, it's only 70. So we are expecting this to be a lot faster. And because we did a loop, it's already looped. So we're going to go ahead and download this program, and let's take it back to the track and see how fast it is. Okay, everybody, the program has been downloaded. So we'll do the same thing that we did before. You go ahead and check your video time when this thing starts, and then we'll just see again how it compares to 42 seconds. I'm expecting somewhere in the 20s. I'm not sure what, but let's go ahead and check it out. So, are you guys ready? 3, 2, 1, go. You can already see that it's making not as wide turns as it was with the brick program. And you know, you guys can, I'm sure you guys have your own line following programs that are a lot faster than this. I'm not trying to be super fast. I'm just trying to get this done. And stop. Okay, let's go ahead and compare times. I have 30 seconds. I was hoping to get in the 20s, but missed it by 1. So, 30 seconds though is better than 42. So, I can go back and tweak the program to make this go even faster. But for now, I just wanted to show you how you can make it line follow both ways, brick program and computer program. And now let's go ahead and get to the part where we add more sensors on here. And for those of you that do First LEGO League, let's show how we can put a medium motor on here that can get First LEGO League missions done. Okay, I have my ultrasonic sensor here, 14-inch cable plugged into it. I have a gray llama piece plugged into one side. What I want to do is just thread this thing through the front first, because I don't want to have an issue of it, trying to plug it in after it's already been installed. That doesn't help. Just gonna put that into the front, plug this into 4, and there we go. There's gonna be your ultrasonic sensor. Let's go ahead and go to the touch. Okay, let's go to the touch sensor now. So touch sensor, I have the same llama piece, but I put in a black connector. I'm going to show you what that's going to do in a second. I'm going to go ahead and put that same 14-inch cable. And then basically watch what happens here. I'm going to have, if you notice here on the front, I'm using that black connector to put it right there in the front. And there you go. So if you're going to use this to ram into something and have it activate the touch sensor, it's all there for you. Okay, the gyrosensor is super easy. Gyrosensor, I just put an H piece in. And just because there's no, it doesn't need to be activated in the front, I can just put it right here. Use my 10-inch cable. Gyrosensors usually default to port 2. And that was easy. Now for those of you that do First LEGO League, let's go to the medium motor and see how we can put that or attach that onto this EasyBot for a simple mission. Okay everybody, let's go ahead and take a look at this medium motor attachment for this LEGO League portion of the robot. So I'm just going to go ahead and plug this 10-inch cable in. I'm going to go ahead and put this red connector right there in the middle. I'm going to go ahead and put this black spin gear on right there. And then I've been doing this trick a lot lately with this medium motor. I have this black T with the 2 black connectors, and I'm going to put it right there. And what it's going to do, it's going to allow me to have, when this gear spins, it's now going to allow another gear to spin so I can grab things with it. Let me show you how I'm going to do that. So I'm going to need another black spin gear, interlock it with the other gear. And you know, this axle size is up to you. I'm going to make this axle size, I think this is a 9, just because I want the reach to be able to be a little longer. So it went through the end of the black T and the gear. So you can see here that it spins both gears like that. And then in order to grab things for like a first LEGO League mission here, I can put on one, I can put on a second one just for good measure. So now you can see how that can be used to scoop something up. I can flip these around and make, you know, grab something with it. Okay, and then I'm just going to put 2 black connectors here. Let's get this robot. If you see here, I have 2 open holes, one right there, one right there. I'll just go ahead and put that in. Put this into port A. And now you can see how it can be used to pick something up. I can, like I said, turn these around. There are some first LEGO League missions where you have to grab something or trap something. So I can have it now come. Oh, that was wonderful. Okay. So you can have it come grab something down, trap something, pull it back. So there's that medium motor attachment. You know, if this gets a little too flimsy, you can always put another piece here, you know, maybe a long blue connector, so that can stay inside of this medium motor also. So there you go.
Okay guys, so there you have it. This guy is really cool. So today, let's recap. We showed you how to just build it. We showed you how it can be used as a line following robot. We showed you how you can attach all your sensors onto this robot. And we can even do some first LEGO League missions with this guy with this medium motor attachment. So it's just a really cool robot. Simple to make, like I said, took me 10 minutes to build it. And you know, Mr. Hino, do you suggest I use this for first LEGO League? I think you can probably come up with something that's a little bit more intricate, you know, better suited for speed and, you know, taking attachments on and off. But, you know, for those of you that are just getting started, for those of you that are just trying to figure something out simplified, you know, it's a really cool robot. So very versatile, especially when you're able to get all those sensors onto this robot. So it would be a great robot to have in robotics class if you're just, you know, trying to use your sensors, trying to figure out how things work. Great robot. Okay guys, hopefully you like the EasyBot with the new ball bearing and just being able to attach all your sensors and your medium motor on here. Okay guys, I am Mr. Hino from Mr. Hino's LEGO Robotics. I'm out.
He's out.
He's out.
We got this.
We got this.
We got this, guys.
Hey guys, Mr. Hino here. Thank you so much for watching. And if you love robotics, don't forget to check out these videos also because they're cool. Okay guys, take care.